Greetings. In this video we are going to derive the relation S is equal to r theta for a circle. S is the arc length, r is the radius, and theta is the angle subtended by the arc. Before we begin the derivation, I would like to say a few words on why I named the video as slightly more accurate proof. So viewers who wish to skip this part, who wish to jump directly to the derivation, may see the description. So why I named this video as slightly more accurate proof is because when one looks up for the derivation of this relation on YouTube, you will find several videos. So there are several videos, couple of videos already that derive this relation, but there are many videos, there are a few videos at least, that use phrases like this in their derivation. So in the course of deriving S is equal to r theta, they use something like this. As we know, the measure of the central angle of the arc is directly proportional to the arc length. We know that the central angle and the arc length are proportional. By geometry we know that blah blah blah. So there are videos which use such phrases and say S is equal to is directly proportional to theta, is something that is known. So if this is taken for granted, then the proof is in a sense not a proof. You are using something to be proved to prove it. So in effect this is not a real proof. So we don't know whether S is directly proportional to theta. So if you are using this and deriving, then in essence you are saying S to some extent you are saying S is equal to r theta because S is equal to r theta, because the constant of proportionality is r, is something that follows easily given that S is directly proportional to theta. So in this video what we are going to do is we are going to show that S is directly proportional to theta, and we will see whether or not the constant of proportionality is the radius of the circle. So let us begin the derivation. Okay, so a few words on something is directly proportional to something. When do we say A is directly proportional to B? A is directly proportional to B when A becomes twice, B also becomes twice. If A becomes 10 times, then B also becomes 10 times, and so on. And secondly, the graph between A and B is a straight line passing through the origin. So our first task will be to show that S is directly proportional to theta. S is directly proportional to theta. So how do we show this? One way to show this is by using integral calculus. So we are going to integrate the length of the arc. So the first thing that we will do is we will consider a certain angle theta, and we will calculate the length of the arc using integral calculus, and then we will double the angle. and see if the arc length doubles as well. If the arc length doubles as well. If it does, then we can conclude that S is directly proportional to theta. And since we are doing two cases, it will be seen that the constant of proportionality turns out to be the radius of the circle indeed. So that will be the algorithm. We will do the integration of the circle. So before we do the integration, for ones who are new to integration, let me just give you a glimpse of what we are going to do. We are going to use a certain formula for dl and integrate dl. dl is a infinitesimally a small length of an arc, and we will integrate dl between desired limits. Alright, so consider you have a function, a random function, Now I want the arc length, the length of the curve between point A and point B, for example. That is to say, I want the length of the curve between these 2 points. So this curve has a certain length, and it is a curve, not a straight line. So it is a continuous curve, and I want the length. So what I can do is I can use calculus. So consider a random point x. Corresponding to this random point x, you will have a certain fx, certain value of f. Now consider a small infinitesimally small length dx around x. So this is dx. So corresponding to this dx, the length of the function will be dl. Now the interesting part about calculus is that when I say around x, it doesn't matter if the dx is to the right completely or to the left completely, or it is exactly surrounds x. It doesn't matter. So it works. If you wish to investigate more, look up Riemann sums, something called Riemann sums, if you are interested. So corresponding to this dx, we have a small curved length dl, and let me blow this part up. So this is the dl, and down somewhere is our x-axis, and this is dx. So this part is dx, and this part is dy, and this is the length of our curve corresponding to dx. Now we can apply Pythagoras theorem and get the following: dl square is equal to dx square plus dy square, and dl is therefore plus or minus under root dx square plus dy square. Negative sign is immaterial because the length of the curve is positive. So dl is equal to under root dx square plus dy square, which can be written for our benefit as follows. So I have taken dx square common, and you see dx square inside the under root can become dx. So this equation becomes the following. Alright, so this is the equation for dl, an infinitesimally small elemental length. Now if I integrate this from a to b, is our limit from here to here, then I will get the length of the curve, this length of the curve in question. This length of the curve will be found by integrating dl from a to b. Let's say the length of the curve is what? See, a to b. Alright, so this is going to be our formula, 1 plus dy by dx whole square inside the under root and dx. So we will use this formula to find the arc length corresponding to a certain theta. Let's say the first theta that we take, let it be 45 degrees, and let's say the second theta that we take, let it be 90 degrees. So in case of 45 we will get some certain s, and in case of 90 degrees we will check if the arc length becomes 2s. We will check. Alright, so let me just take up a new paint slide. Let me take the formula as well. This is the formula from A to B. This is the formula for arc length. From A to B. Now, notice that dy by dx is the function, the derivative of the function. So I can well write the arc length as 1 plus f dash is the derivative of f squared inside the under root dx, integral from A to B. By the way, this formula is actually this. I mean, in the answer you put the limits. Alright, so this is the formula that we are going to use. Now a circle, if you draw the x and y axis, let this be the y axis and let this be the x axis. X, y. So what is our function going to be? Our function, as you must be knowing, the equation for a circle is, for this circle is x square plus y square is equal to r square. So I can write y, which is our function, y which is f as a function of x, is equal to r square minus x square under root plus under root for this part. And since we are going to take this as 45 degrees and then double it up to 90 degrees, you see this is actually plus or minus, but that doesn't matter. We consider only the plus part. So only this first quadrant of the xy plane is taken into account. Alright, so putting this value of f in our formula for theta is equal to 0 to 45. So for theta is equal to 0 to 45 is equal to 0 to theta is equal to 45 can be written as x is equal to r 2x is equal to r by root 2. You can work this out. So if you rotate this by 45 degrees, then this length will be r by root 2. So we have to integrate our function, our formula from r to r by root 2. So our integral will be something like this, r to r by root 2. And if you take the derivative of f, this part, for our function, I am not going to do the entire derivative. I will directly write the answer. This integrand part, if you work out for our function, then you will get the following. Dx. And further, you can solve this integral. You can solve this integral using mathematics, of course. But I am not going to solve this again. Solve this entirely. I will directly write the answer. But if you wish to solve this integral, let me give you a hint. Not a hint. The main thing that you need to solve this integral, which is as follows. If you have an integral of this form, a square minus x square under root, then the value of this integral is sine inverse x by a plus c plus a constant. So you can use this form and apply it over here, and you will find that our answer turns out to be r in the bracket sine inverse r by r, the first first limit minus sine inverse r divided by under root 2 from divided by r. And if you solve this, you will get r pi by 4. So the arc length from theta is equal to 0 to theta is equal to 45 degrees is r pi by 4. R pi by 4. So this is for this set of limits. Now what we are going to do is, we are going to integrate the arc length from theta is equal to 0 to theta is equal to 90 degrees, and let us see if the arc length doubles. So let me take another paint slide. Alright, so let me take the formula as well. So this is the formula for arc length of any curve, of any function. Alright, so our function is y is equal to r square minus x square under root. So this is our function, and we are going to integrate this time from theta is equal to 0 degrees to theta is equal to 90 degrees, and the value of r corresponding to these thetas is x is equal to values of x corresponding to theta is equal to 0 is r, and for theta is equal to 90 is 0. So this is our y axis, this is our x axis, So now we integrate from, our integral will be from r to 0, 1 plus f dash square and so on. So again the integrand will be the same, r divided by r square minus x square under root dx. So what you have to do is take the derivative of this function, put it over here, and then you will get this. Alright, so again you can use the form that I just mentioned before, and after using the form and working out the math, you will find that this integration equals r in the bracket sine inverse r by r minus sine inverse 0 divided by r, and this value turns out to be r pi by 2. So our arc length for the second case is r pi by 2, and our arc length for the first case was r pi by 4. So what do we have here? When we took theta is equal to 0 to 45 degrees, our arc length was this, and when we took theta is equal to 0 to 90 degrees, our arc length turned out to be this. So when we doubled the angle, our arc length also doubled. Pi by 2 is twice of pi by 4. So since doubling the angle doubles the arc length, we can say that theta is directly proportional to s, or s is directly proportional to theta. And you notice in both the cases the constant r is the radius of the circle, which is a constant. So the constant of proportionality is indeed the radius of the circle, and therefore we can write s is equal to r theta for a circle. Thank you for watching.